that is about regarding supervised learning network. I will share my screen and associate memory. This is the discussion. I want to post in chat box. This is the discussion. What we required is about supervised learning and associate memory network. Unit structure is like this: objective, graph propagation network, radial functional link network, tree neural network, wavelet neural network, training algorithm for pattern association, auto-stick memory network, auto-associate memory network, understand used in real-time applications. Objective, theory behind area basis network and its activation function, such as timeline. Uses gradient descent method to calculate error and propagation it back to the hidden unit. The training back propagation is performed in 3 stages. First one is the feed forward. The network of the input pattern. Second one is the calculation propagation of the error. Third one is weight updates. The input layer section is the first section. See the architecture of the back propagation network. Second section is the hidden layers. Third section is the output layer. Different point is a back propagation neural network is a multi-layer feed forward, a hidden layer and output layer. The second point is the neurons present in the hidden and output layers have activation with always value 1. The third point is the basis also acts as weights. The fourth point is during the learning phase, signals are sent into the reverse direction. The fifth point is the output obtained can be either binary or bipolar. Basis function network. The radial basis function is a classification and functional approximation neural network. It uses nonlinear activation functions like sigmoidal and Gaussian functions. Since radial functions have only one hidden layer, the convergence of optimization is much faster. The subpoints is architecture consists of 2 layers. The second point is output nodes from a linear combination of the basis functions compared by means of radial basis function nodes. Hidden layer generates a signals corresponding to an input vector in the input layer, and corresponding to this signal, network generates a response. Just see the architecture of the input layers, hidden layer, output layer. Just examine the architecture overview. This is the architecture overview. How the hidden layer is, how the output layer is. The layers you can examine in the diagram itself very clearly. Okay, how these layers are connected one under each other. Okay, how they are connected one under each other, the layers. Okay, that is the architecture of radial basis function. Time delay networks are basically feed forward neural, except the input waits has a trapped delay line wait. In time delay neural networks, output is being fed back through a unique delay into the input layer. The net computed is equivalent to an infinite impulse response filter. A neuron with a tapped delay line is called time delay neural network unit. A network which consists of time delay neural network consists of units is called time delay neural network. Applications to TDM time neural network is speech recognition. Functional link networks, please diagram. Functional link networks is especially designed higher order neural networks with low complexity for handling linear non-separable problems. It has no hidden layers. This model is useful for learning continuous functions. The most common example of linear non-separability is XOR problem. So, sin pi x, cos pi x, sin pi x, cos pi x, sin n pi x, like x1 to input, x2, x3, x4, x5, xn, all are XORed with a y. Y is equal to f of x. This is the functional line network model with no hidden layer. Pre-neural networks. These networks are basically used for pattern recognition problems. It uses multi-layer neural network at each decision-making node of a binary classification. For extracting a non-linear feature, the decision nodes are circular nodes, terminal nodes are square nodes. Just see that logic here. The decision nodes are circular nodes and terminal nodes are square nodes. Very key point I want to post here. The decision nodes are circular nodes. Terminal nodes are square nodes. The splitting decides whether the pattern moves to the right or left. The algorithm consists of two phases. One is growing phase. It is very important algorithm in the application point of view. One is called growing phase. The other one is called pruning phase. The growing fish is a large tree is grown in this space by recursively finding the roots or splitting until all terminal nodes have nearly pure membership or insect can split further, pre-pulling to overfitting of data. A smaller tree is selected or it is pruned. Neural networks diagram. User waveform recognition problem. See the binary classification tree here. Wavelet neural networks. This is very important. These networks work on wavelet transform theory. Wavelet transforms are very important. It is useful for functional approximation through wavelet decomposition. It consists of rotation, dilation, translation, and if the wavelet lies on the same line, then it is called. Just examine the diagram. Okay, rotation, dilation part, okay, and this wavelength part, translation part, input, and those blocks indicate into a number n. Output y. Wavelet neural network with translation, rotation, dilation, and wavelength. Associate memory set that maps the set of input patterns to the output patterns. It can store a set of patterns as memories. The recall is through association of key patterns with the information memories. Associate memory makes a parallel search in a stored data file. The concept behind that is to receive stored data either completely or partially. This is a very important algorithm. Practically, they have a lot of importance in the application-oriented point of view. Has a lot of importance in the practical application point of view. Now, unsupervised learning. The next topic is unsupervised learning. Unit Lexicon HatNet, having Cohen self-organization feature maps, Cohen self-organization water map, lightning vector quantization, counter propagation networks, adaptive resonance theory network. In this learning, there exists no feedback from the system environment. W indicates the desired output of a network. Network by itself should discover any relationships of interest such as features, patterns, contours, correlations, or classification in the input data and thereby translate the discovered relationships into the outputs. Such networks are also called as self-organizing networks. An unsupervised learning can judge how severe a new pattern is to typical pattern already seen, and the network gradually learns what similarities that the network may construct a set of axes along which to measure. Similarly, to previous patterns, that is, perform multiple component analysis, clustering, adapt to vector quantization, feature mapping. For example, a net has been classified the input patterns into in the output classes, say P, Q, R, S, R, T, that may respond to both the classes P and Q, RS, and S. In the case mentioned, only one of several neurons should validate structure by means of which the net is forced to make the decision. Only one unit will respond. The process for achieving this is called computation. Practically considering a set of students, if we want to classify on the basis of evaluation of performance, their score may be calculated, and one just understand the logic. One whose score is higher than others should be the winner. Should be the winner. The same principle adopted here, followed in the neural networks for pattern classification. In this case, there may exist a type. A suitable solution is presented. We may also call commutative nets. The extreme form of these commutative nets is called winner take all. The name itself implies that only one neuron is the competitive group which possesses a non-zero output figure at the end of the computation. There exist several neural networks that come under category. To list out a few, counter propagation net, learning vector optimization, and adaptive real estate. These are all very important. These are all very important. In the application point of view also, subject point of view also, to get a good marks, they are very important. The learning algorithm is used. Most of these nets is known as coherent learning. In this learning, the units updated their weights by forming a new weight vector, which is a linear combination of old weight vector and the new input vector. So the learning continues for a unit whose weight vector is closest to the input vector. The weight optimization formula in coherent learning output unit J. See the equation Wj of mu equation. W theta j of world plus alpha of x minus W theta j of world, where x is the input vector. Wtj is the weight vector for unit j. Alpha learning rate whose value decreases monotonically as training continues. There exist two methods to determine the winner of the network during the computation. One of the methods for determining the winner uses square of the Euclidean distance between the input vector and weight vector, and the unit whose weight vector is at the smallest Euclidean distance from the input vector is chosen as the winner. The next method uses the dot product of the input vector and weight vector. The dot product between the input vector and weight vector is nothing but the net inputs calculated further. corresponding duster units. The unit with large dot product is chosen as the winner, and the weight updation is performed over the it because the one with the largest dot product corresponds to the smallest angle between the input and output vectors. If both the units commutative nets are those where weights of computation is used among the neurons for enhancement of contrast in their activation function. These are MaxNet, MaxCanNet, and HammingNet. These are all the fixed weight commutative nets: MaxNet, MaxCanNet, and HammingNet. MaxNet. The MaxNet services as a subset net of picking the node whose input is larger. Architecture of MaxNet. See this diagram. Where fixed symmetrical weights are presented over the weight interconnection. The weights between the neurons are inhibitory and fixed. The MaxNet with structure can be used as subnet to select a particular node whose net input is largest. Testing application algorithm MaxNet. Step 0. Initial weight and initial activation are set. The weight set 0 less than t less than 1 by m. So m is the total number of nodes. Just see xi of 0 is equal to input node capital Xj. Wij is equal to 1 when I equal to j. Just don't miss this logic. And it is minus epsilon if I not equal to j. Step 1. Perform. Step 2 to 4. When stopping condition is false. Step 2. Update the activations of each node for j equal to 1 to n. Xj of n epsilon w. F of xj o comma d minus epsilon I not equal to j, that x of world. Step. Save the obtained used iteration, next iterations. It's an iterative method, of course. MaxNet is a iterative method. See from architecture onwards. Finally, test the stopping condition for convolutional network. The following stopping condition. If more than one node has non-zero action, continue else step. MaxCanNet. Okay. So MaxCanNet network, which is more generalized contrast enhancement network compared to the earlier MaxNet. There exist several cooperative neighbors, numerous in close proximity, to which every other neuron is connected by extrinary links. Also, each neuron is connected to over inhibitory weights. This is the technical word. Extrinary links. Inhibitory weights. inevitably waits. To a number of competitive neighbors, neurons present further away. There are several further neurons to which the connections between the neurons are not established. Here, in addition, connections within a particular type of neuron and net neuron receive some other external signals. The interconnection patterns are repeated for several other neurons in the layer. Architecture of Mexican hat net. The Mexican hat net is shown in figure. All are similar architectures. The only the change is conditions. Please try to observe. Depending on the application, depending upon the program, you can understand more on this application-oriented point of view. But all these architectures and algorithms have practical-oriented importance. Architecture of Mexican hat net. The architecture of Mexican hatchet node is shown in again a figure. It is completely different architecture with inputs up to some n powerful transforming weights. The architecture of Mexican net with interconnection patterns of node Xi. The neurons here are arranged in linear order, having positive connections between Xi and near neighboring units, and negative connections between Xi and further away neighboring units. The positive connections region is called region of cooperation, and negative connection region is called region of competition. The size of the region depends on the relative magnitudes exist between the positive and negative weights, and also on the topology of the region such as linear, rectangular, hexagonal grids. Just see these technical words: linear, rectangular, hexagonal grids. They are the very important technical words. In a Mexican hat, there exist two symmetrical regions around the individual neuron. The individual neuron is generated by caplexer. This neuron is surrounded by other neuron Xi plus 1, Xi minus 1, Xi plus 2. The nearest neighbors to individual neuron Xi. Hence, the weights associated with those considered and denoted by W and W. The farthest neighbors, M individual neurons Xi are taken Xi plus 3 and Xi minus 3. The weights associated with these Xi plus 4, Xi minus 4 are not connected to the individual neurons Xi, and therefore no weighted interconnections exist between these connections. To make it easier, the units present in the radius, the units with radius 3 are connected to the negative weights, and the units present away from the radius 3 are not connected in any manner. Okay, for the neuron Xi. Flowchart of Mexican het net. The flowchart of Mexican het net is shown in figure. This clearly depicts the flow of process performed in the Mexican hat net. Start Initialize radius of region. Interconnection with the radius of and set the weights. Set vector and architecture. External signal input. Iteration curve. Equation sets series flow. Apply the activation functions. Store the recurrent acknowledgement. Algorithm of Maxet AtNet. See the algorithm. The various parameters used in the training of the connection. Xi plus k and xj minus k are interconnected individual nodes. R1 less than R2 is the one of the condition. Weights between xi and xi plus k and xi minus k. Signal exam, vector activation in previous time step. Tmax is equal to total number of interactions of contrast enhancement. Here the iteration started only with the incoming of the external signal presented to the network. Step 0, the parameters R1, R2, Tmax are initialized accordingly. Initialized weights as k is equal to C1 or k equal to 0 to etc. R1. Wk is equal to Ck, etc. C1, C2, C3, C4, C, etc. See the logic on the algorithm. Input is external signal S. These all algorithm share. Algorithm steps are derived from the architecture. Each and every is very much useful to write a code. In where it is used, this algorithm MaxIcaNet, that's most important. Where it is used, you can use in the networking part. And we can use these parts in the computers, or we can use them in a particular applications of the building an architecture, to build an architecture of the server or a client. These type of algorithms and steps are very much used. Step 4, apply the activation function. Step 6, increment the iteration counter. 7, test stopping condition like this. Hamming network next one. The Hamming network selects and stored classes which are maximum in Hamming distance h from the noisy vector present. Input the vectors involved in cases are binary. Bipolar Hamming network is a maximum likelihood classifier that determines which several exemplar vectors, the weight vector per input unit, and clustering nets is exemplar vector of code book vector for the pattern inputs cluster unit is most similar to input vector. The difference between the number of components and the Hamming distance between the vector gives means measure of similarity between the input and output vector and store. Example vectors is already discussed in the Hamming code distance. Between two vectors is the number of components in which vectors differ. Consider two bipolar vectors x and y. Use a function x dot y is equal to a plus b. Okay, some computational function, mathematical function. Of course, it is where a is the number of components in which vector agree and vector disagree, like this. And write. See the equations. Be very particular on the equations. Vector agree and vector disagree. Simplifications of simple mathematics. Dot of y is equal to a minus d. X dot of y is equal to a minus of n minus. Get a value of a. Accepted value. From the above equations, it is clear to understand the weights can be set to one half of exemplar vector and bias can be set in each unit with largest net input. The net is able to locate particular unit that is closest to the exemplar. The unit is the large architecture of the Hamming network. Architecture of the Hamming network is shown in figure. The Hamming network consists of two layers. The first layer consists distance between the input vector x and stored pattern vectors and feed forward path. The efficient response in this layer of neuron is the indication of minimum Hamming distance value between the input and the category, which is this neuron represents. The second layer of the Hamming network is composed of MaxNet. It is called subnet. Technical word is subnet. The winner of all networks, which is a recurrent network, the MaxNet is focused to suppress the value of the MaxNet output code mode except the initially maximum output code of the first layer. See the diagram. Structure of Hamming network. I want to enlarge this structure. Just examine the different nodes and neurons in this structure. Different neurons. Different nodes in this structure. Testing the algorithm of Hamming network. Given bipolar input vector is x, and for a given set of m bipolar exemplar network, say E of I, E of j is equal to E of m. The Hamming network is used in exemplar vector that is closed from the element vector. The input is entering yj. Given the measure of the similarity between the input vector and example vector, the parameters used here are the following. N is equal to number of input units, number of output units, E of j, j exemplar vector, E1 of j, E2 of j, like En of j. E. The testing algorithm Hamming at is step 0. Testing. For I is equal to 1 to n, j is equal to 1 to m. You can test that algorithm. Step 1. Perform step 2 to 4. Input vector is x. Step. Calculate the net using your weights and corresponding inputs. Step 3. Initialize the activation of MaxNet. It's very simple once you observe. MaxNet is bound to iterate. Exemplar of the machines of input patterns. Full self-organization feature maps arbitrary dimensionally into a response of one or two dimensional arrays of neurons. That is, it converts performing such a mapping is called feature map. Apart from its capability to adjust the higher dimensionality, it has no preserve the neighborhood relations of the input patterns. That is, has to obtain topology preserving the map. For obtaining such a feature maps, it is required to find self-organizing array, which consists of neurons arranged in a one-dimensional or a two-dimensional array, like that you can observe the mapping network. That is, this is a two-dimensional feature of the mapping network. Okay. Just see the arrangements. One dimension, one box. Two dimension is two box with some number of rows and columns. Okay. I given concept before. Architecture of cone self-organizing algorithms. Architecture and algorithm steps. They are very important for each and every. Okay. Consider linear array. For rectangular neighbor, radius and figure. In all three cases, you observe that for all rectangular grid neighbor, like the linear array cluster units, rectangular grid. See how the structure is designed. Rectangular grid. Next one is hexagonal grid. Shape is hexagonal. Rectangular means rectangle. Shape is rectangular. Circular grid means also the shape is circular. Circular grid has its own application. Rectangular grid has its own application. Okay, hexagonal grid has its application. Depending on the application, the shape is designed. Okay. Coherent self-organization feature map architecture, just observe, it is very simple. Input weight vectors and output. Okay. Flowchart of coherent self-organization feature maps. Set, initialize the weight learning rate. Initialize the topic x for I equal to 1 to m, j equal to 1 to m. Calculate the square. Obtain the unit index in j. Weights of the winning. Continue. Reduce the training. Reduce rates of topology. This is a flow process. KSFOM algorithm. Just see the steps involved. That is as the first one. Initialize learning rate alpha. Step 1. Perform some steps. Perform some steps. 3 to 5. Step 3. Compute the step. Step 4. For winning the index I. Step 5. For all units j within specific neighborhood. Step 6. Update learning alpha using the formula network. Constant self-organization. This is very cool. I explained. The shapes is a two-dimensional view of box. The number of separable holes. I explained different shapes also, like that. The extension of constant map for a multi-layer network involved the self-organization feature map. Layer, the output node is found to associate desired output values. The input map and layer that is added is called motor map, in which the moment it and Next class I will discuss about learning vector quantization. This is completely different topic. Learning vector quantization methods and their associated topics. I want to stop here. Okay, thank you all. But learning vector quantization part is architecture and algorithm steps. Concept architecture, diagram, algorithm steps. If you understand that, you can understand every topic also. Algorithm steps. Okay, like that. Okay, for each algorithm that is important. Okay, thank you, one and all. Thank you so much. I will post important things to you also. Just observe. Okay, thank you. Thank you so much. We will continue in the next session. Important topics. But don't forget about architecture and algorithm steps. Thank you.